Okay, so we're going to go over a specific kind of reaction here that's an aldol dehydration. So previously we saw what happens with aldols, and now we're going to dehydrate them. And it's not that different from when we had, this sort of thing where we had an alcohol and there was an H here, and we heat it in the presence of acid, and we end up making a new double bond. It's a lot like that. So if we end up having two aldehydes and they end up reacting together, then we end up with this COH, H, CH2R. So basically, it's this whole bit of the molecule right over here, just like it was before. This O was this one over here, two of those molecules. So that's our aldol. And now we heat it in the presence of an acid. This carbon is still this carbon, so it comes over here, and we end up making a new double bond where that used to be. The OH is gone, so there is still an H attached to it, and then CH2R. Okay, so all of these things are new to it before. And there's a specific kind of reaction that is, the product is an alpha-beta unsaturated aldehyde, and the specific kind of reaction that it is a, it's called E1CB reaction, and that is elimination unimolecular conjugate base reaction. What's really important is that if you see that we start with an aldol and then we end up dehydrating the aldol, that's the kind of thing that we end up making. Now, I'm not really going to go through the mechanism of it, but just to show you an example, if we have two of these guys react, the first thing is to identify where the alpha hydrogen is going to come from. Well, this carbon has no hydrogen, so it's not going to come from there. So it's going to come from here. So our alpha hydrogen ends up coming from here. And so when it does, the thing that we end up making here is we have a carbon that'll have an OH on it now. And this carbon also has a hydrogen on it. And now we have a benzene ring on there. So this is the molecule that I went up making here. I made a mistake earlier, so that's just all scratched out. And then if we were to dehydrate that acid in the presence of heat, we're going to form this species here. So this this benzene ring is this benzene ring. So now we have a CH doubly bound to this CH. So one of these H's gets removed, going to a C double bond O compound here. So that's the kind of product that ends up coming out of that. And man, do we have a lot of conjugated double bonds there. That is probably super, super stable. So that's aldol dehydration. But the more interesting thing here is this. Now, do not lose your minds on this. This is just impressive. So this is what's called a crossed aldol addition. And if you're following along in Bruce, it deals at 7.12. But basically, let's say we have two different carbonyl compounds. So we have this one with an ethyl and this one with a methyl. They're both aldehydes. And so this one can lose a hydrogen from here, this one can lose a hydrogen from here. Well, when we do that, we can get up to 4 different products, and wow. All right, so let's see how that ends up happening. So the first thing that happens is base removes one of our hydrogen, the alpha hydrogen from here, or it can remove it from here, making this species, in the case of the ethanol, the ethyl, or the propyl one, if you want to say that, and this one here for the ethyl one, if you want to end up saying that. Now, this can react with itself, okay, so CH3, CH2, C double bond OH, and if that reaction actually ends up happening, let me show part of the molecule in red. Okay, so this is the molecule that did the first part of reacting.
Can I play on my tablet?
Yeah, you can play on your tablet, go ahead.
I didn't play it.
I know. Okay, so we have that happening here, and so it forms a bond with this, which makes a COH, and attached to that is this H here, and this CH2, CH3. So that's the first of the 4 products that can get made. It can also react with this other compound over here. Okay, so if that is what ends up happening, then we end up getting, well, let me draw the original part here in red. So here's our original carbonyl, CH3. So that's the original part of the molecule, and then the part that ends up getting added is a carbon that's going to have an OH attached to it. So this oxygen is this one over here. It's attached to this hydrogen and this CH3. So that is two distinct molecules that end up coming out of that. If our base ended up taking off a hydrogen from over here, this molecule can react with itself. So CH3, C double bond OH, and if that reaction ends up taking place, this might be a good place for you to pause and see if you can determine the reaction, the product that's going to come out of this reaction. And let's see if you agree with me at the end here. So starting with, you know, the original part of the molecule, so C double bond OH, CH2, there's the C with the OH on it, H and CH3, so that's another compound that can be made if it reacts with itself. And it can also react with the other compound that's there. Okay, and if it does, then let's see what product that is. Again, good place to pause and see if we can arrive at the same conclusion. So there's the original part of the molecule, and then that would react with the other molecule to make this, CH2, CH3. So there are 1, 2, 3, 4 distinct products that can end up being made. And that's a big number. So in the next video that I do, I'm going to show you guys how a couple strategies that we can use that might cut that down to a manageable 1 or 2 products. Okay, thanks. You can go play on your tablets now.